Let's move on with question number 1155, number of dice rolls with target sum on LeetCode. The given question is that you have n dice and each die has k faces numbered from 1 to k. Given three integers n, k and target, return the number of possible ways out of the k to the power n total ways to roll the dice, so the sum of the face up numbers equals target. Since the answer may be too large, return it modulo of 10 to the power 9 plus 7. Okay, so according to question, what are we given are a value n, k and a target, and n are the number of dices, k are the number of faces in each dice. So every time we roll a dice, we find some face, right? So the face, total number of faces that add up every time we roll a single dice, so the sum must add up to equal to be target, and we need to find how many such occurrences, how many number of times we can sum to target. So given an example, we have only one die with faces 6, so and the target is 3, so the number of ways we can go about that is only 1. And if we have two dices with 6 number of faces, then target is 7, then the output is 6. That is, you could get a 1 from the first die and a 6 from second, a 2 from the first and a 5 on the second row die, and so on. And if there are 30 number of dices with 30 faces and the target is 500, this is the output, and it's a very big number, so we just did modulo to get this output. And given is target is from 1 to 1000, and the value of n and k is always from 1 to 30. So let's take an example where n equals to 3, k equals to 6, target equals to 7. Okay, so we have 3 each die of number of faces 1 to 6, and again, so I'll just list them all out here. 1 2 3 4 5 and 6. Now to receive this target, so what will we do by your intuition? So you just take a value from here, a face from here. Suppose we get choose a face 1, then the next thing we do is we keep this face 1 as a constant, and then we now find the one of the values from here. So now we take one of these values, so a 1 plus 1 equals 2. So now to reach the target value 7, what is the phase that we actually need? It's 5, right? So we just need to find from here, look into the next die and find our value, and then we return a value, return 1 if we found that, and if we didn't find that, we return a value 0. So what we're actually doing is we are picking one of the values from here, keeping that constant, and picking value from here, keeping that constant, and again picking value from here. So it is kind of like a recursive function. So let's start with that. Let's create our recursive function. Function will pass the value n and target t. Okay, and if t equals to 0, which means that if we have reached end, okay, I'll just write that down in the very end. Let's write our the recursion. Let count equals to 0, and now we are, for every every die we have a target value, right? So we have a target value 7 initially, and here we choose one of the faces. So, and again, like once we chose one of the faces, we chose a so here target is equals to 7. Now once we chose a value of f of 1 from this one, then our target here is equals to 6 with f equals to 1, target is equals to 6, and so on. So what are we going to do is, now with the given target and the given value n, we need to find look for different faces for let I equals to 1, I is less than equals to k plus plus, and we are just going to add to the count plus and helper n minus 1 comma target minus I. It's actually t minus I. So yeah, so what are we doing is, now we are going to the next die with, and our target is reducing by the face we chose. So we are just going to do a modulo here according to the question, because it could be a very large number. So I'm just going to define a const okay. So modulo of mod, and I'm going to return count. So the time where target is equals to 0, which means that we have reached the value. But in the case, like, there could be cases where like suppose we chose a value 1 here and a 6 here, so 6 plus 1 is 5, but we only rolled 2 dice here. The third dice is not rolled and there is no value 0. So only if the value of n is equals to 0, which means that we have rolled all the dice, and only after that we will actually return a value 1. So what are we going to do is, and check t is equals to n, or we could just do n equals to 0, n equals 0, and then call the helper function with n comma target here. So the problem with this function is actually it's very time consuming. So let's just try running this code. So let's just use 2 of these test cases and see what happens. Okay, I guess there's some problem here. Exceeded. So we call the function n comma t, if t equals 0, return n equals 0, count equals to 0, we add to the count helper function with n minus 1 t minus I modulo so we also need to check if n equals to 0. In that case, we're going to return a 0 because t was not found to be 0. Yep. So that's these two test cases passed, right? These two test cases passed. But what if we had the extreme test, like values are 30, 30 and 500? In this case we'll get a time error, runtime error, and let's just calculate the time complexity of this one. So yeah, time limit exceeded, and the time complexity is actually O of since we're going over one for loops, this is O of n, and the helper function is being called multiple times within this for loop. So O of n times helper function, so of n times O of n, so it's O of n squared or O of n cubed probably, so it's like very huge. So what we could do is we could just simplify this by using Memoization, so that we do not have to keep calculating the values which we have already calculated. So I'm just gonna create an array of length n plus 1, why n plus 1? Because our n is index 1, starts from index 1, so that's why. And now for I equals to 0, I is less than n plus 1, I plus plus, and dp of I equals to array. So I'm just creating a new array of, again, length target plus 1. Why target plus 1? Because the things that are changing here are n number of dice and the value of target, so that is what I'm doing here. Target plus 1 dot, so I'm just going to fill them all with the value -1 here. And now I'll change my this function, helper function here. So if we have already have the value of the die with the target, that is, it is not equals to -1, return dpn and the value t. So we're just going to return that, else we calculate everything and then we store the values in the dp before we return the values. So let me just try and run this one. Okay, oh, I'm so sorry, this is t here. Okay, so there's some problem here. Or 10,9 plus 7. This should be working. Yep. Okay, so let's just submit this one. Okay, so this is what we got. Now let's use the tabulation form. So all we need to do is, I'm just gonna get rid of this function call here, and we will need the dp, we'll need the mod, we'll need the dp, and now we don't need this thing, we don't need this thing as well. And here, yep, so we need to define a base case. So at 0 0 just write to 1 in the case where there are 0 number of dice and 0 target value, then we return value 1. And I'll fill up all of this with the value 0. And now we don't need the count. Now we'll create a for loop, let equals 1, I is less than equals to, and number of dice add plus plus, and then the target. Since we are changing the number of dice and the number of targets, so we'll do that for let j equals to 1, j is less than equals to target j plus plus, and now finally the faces. We'll check each of the face. 1 f is less than equals to k f plus plus. And now here what are we doing? We are adding to the TP. So at I and j position, just we are doing the same thing, but instead of adding to the count, we're adding to the TP. So TP I j plus, and here we go over to the TP. We're doing n minus 1. N is the dice, so we do I minus 1, which is the die, and t minus I. T here implies target, which is j, so I'll just do j minus, and I implies the face, and face here is f, so I just do that, and modulus mod, and I get rid of this. So since we are returning, we'll just return our DP here. DP n target. So this is what we are going to return. So the time complexity for this one is O of n cube, because we have 3 for loops here. Actually it's O of n times the t times k, and times target times tk, and the space complexity is O of again O of n times target. Okay, so let's try and run our code. Oh, sorry. So we have a problem here, not a number. Alright, so we need an if condition here as well. If in the case j minus f is less than 0, we are just gonna break the loop, because we don't want this to be negative. Cool. So let's submit that, and so yeah, so definitely the runtime was much lesser than the previous one. Okay, thank you.